Hey, the last part of this linear function review has to do with parallel and perpendicular lines. Our species loves to organize things, and whether you look at our cities, our graph paper, our notes, you name it, just constant sets of parallel and perpendicular lines. So just a quick review. You might want to put this in your notes because it's going to come up time and time again. When we talk about a function, and we talk about two functions, what we're saying is they are parallel if. So the second function is parallel, or the second line is parallel to the first if, right? What do we know about the slope? Well, it's got to be the same. So we're talking the same slope. Hey, what is going on here? Same slope. Well, what about the y-intercept? Well, anything not equal to b, right? If it's exactly the same, you've got lines that are one on top of the other. So it can be up or down, it doesn't really matter. As long as the second line does not have the same y-intercept and has the same slope, then those lines are parallel. When we think about perpendicular, the technical term is the opposite reciprocal. How do we write that? Negative is opposite, reciprocal is 1 over m. So whatever the slope is on the original function, you would take the opposite reciprocal of that. And as far as the y-intercept, it can be anything, okay, including what b is. I think the best way to look at this is just through two problems. We're going to go ahead and look at these together, and you'll see it's pretty easy. Find the equation of the line that is parallel and passes through a point 1, 5. So what this question is asking for is find the equation y equals mx plus b of the line that is parallel to this one and passes through a certain point. Well, the first thing you need to just identify right off the bat is what is the slope of this line? Well, and if you look at it, okay, let's pick points. Well, there's a point right here, a guaranteed point right here. Maybe I'll do this in yellow so it just jumps out a little bit more. There's a point right here and there's a point right here. Okay, well that means right off the bat I should be able to identify what the slope is. The rise, well, it's going down. 1, 2, 3, 4, 5, 6. So it's negative, oh, that's good. I don't know if that'll show up. Negative 6 over, what's the run? 1, 2 over 2. So that's going to simplify to negative 3. So the slope of this line is negative 3, which means the slope of the line parallel to it has also has to be negative 3. Let me click in there and just add this. So now I've got y equals negative 3 times x plus b. So what do I need to do next? I mean, what does it say? That passes through the point 1, 5. So let's say, where is point 1, 5? Well, 1, 5, 1, 5 is right here. So we're saying, oh, we gotta find a line that passes through this point, 1, 5, right here. And the question is, how are we going to do that? Now, some of you may look at this right off the bat and just say, well, wait a minute. It's this line shifted up 2 units. And if you can look at it and identify that, that's absolutely correct. In fact, if you look at this line in purple here, you could say, well, this is really y equals negative 3x. And what's the y-intercept? Plus 6. Well, then, with that in mind, if you want to shift this up 2, if this point gets shifted up 2, then simply, we know that we're going to have to end up with y equals negative 3x and 6 plus 2, trying to make it there, is going to be 8. So that's a visual way to represent a translation shifting something up. Algebraically, if you want to do it, well, hey, you can do it too. Let me just show you. What you need to do is plug in the x and y coordinate and solve for b. So in this case, y is coming right here. It's this 5. So 5 equals -3. The x-coordinate is 1 plus b. All right, so 5 equals -3 plus b. And how are we going to solve this? Well, we're going to add 3 to both sides. So plus 3 plus 3. And of course, now you know that b equals 8. And of course, that just throws you right back to the beginning. It says, oh, well, that's what we said. Y equals -3x plus 8. I hope that's a helpful example. What I'd like you to do right now is try this problem. A little bit different. Find the equation of the line that is perpendicular to this line in purple and passes through the point 1, 5. So go ahead, pause the video, try this problem on your own, and see what you come up with. All right, welcome back. What did you come up with? Well, first of all, we know that the slope of this line is -3, which means perpendicular, the slope has to be negative, the opposite reciprocal of 1 over -3, which is simply another word of saying 1/3. So the slope of the line that's perpendicular, 1/3, is going right into here. Now, in this example, I'm not using point slope form, I'm using slope intercept form. But in either case, I'm going to come up with the same thing. Graphically, I can go to the same point, 1, 5, right here, and I can draw, the line going through it with that slope. So I can go rise of 1 over 3, 1, 2, 3, right? And I can draw a line through it like that. And of course, that's going to be a 90-degree angle. You guys remember that from geometry. But let's look at the algebra here. So y minus 5, right? Again, in this case, I'm using point slope instead of slope intercept, right? Equals 1/3 x minus 1. I'm distributing the 1/3 to both terms. Now I'm going to add 5 to both sides, and you should get a final equation of y equals 1/3 x plus 4 2/3, or I think that works out to be 14 over 3. Either way, whether you chose to do slope intercept or point slope, or you shifted it and determined what the function was, I hope that you've got a better sense of what to do with parallel and perpendicular lines with regard to linear functions.